Good morning, all. Now we are going to discuss about the most important concepts in RDBMS, which is normalization. So first, what is normalization? Normalization is a main process which is mainly used to reduce the redundancies, which means duplications. We have to avoid the duplications in relational database management system. That's why we are going for this normalization concept. So it is a systematic process in database which is used to organize the data efficiently, reduce redundancy, and we have to avoid all the anomalies like insert, update, and deletion anomalies, and improve data integrity. Finally, it will be divide a large table into smaller related tables using some primary keys or some foreign keys. First normal form. So a relation is in the first normal form if it is every attribute in a single valued attributes, or we can say like atomic values, or it does not contain any composite or multi-valued attribute. This is the condition for first normal form. What is the rule for this first normal form? So all the attributes, which means the columns, contain the only atomic or indivisible values, and each column contains the values of single type. And then each record, we can say like a row, which will be unique, meaning it can be identified by a primary key. So there is no repeating groups or any arrays in any row. So this is the main conditions or constraints for creating a first normal form. So this is the initial table. So we can say like it is an unnormalized data. So here we have been four columns, which means student ID, student name, courses, and then instructor. So here we have some repeated groups. For example, in the same row, we can have multiple elements like DBMS, AI, and then both instructor, which means Dr. Smith and then Dr. Allen will be considered in the same row. So what is the rule for achieving this, reduce this redundancy? So we can split the table into multiple tables. So split the multiple values in the courses and then instructor into separate rows. So we can have like two separate rows. For example, student ID S101 having the name John and having the study, which will be studying the course called DBMS. The instructor is Dr. Smith. The same will be applied at, but the instructor is Dr. Allen. So we have to split the table into two tables. That's why we don't want to update all the data in the other tables. So this is the first normal form. So another example this is. So here initial tables we can see like unnormalized data. So we have to split it into n number of rows, which means we have to ensure that there's no repeating groups. So that we have divided the ID 1 having a name A and C1 courses. Some same the ID 1 having a name A and then C2 courses. So and so on. So next normal form is second normal form. So what is the condition for the second normal form? It must be in first normal form. So there is no partial dependencies. Partial dependencies means in which all the non-key attributes should depends on the whole primary key, but that does not to be a part of it. It will be based on the fully functional dependency. And we can organize the database table so that it reduces the redundancy and ensure the data consistency. So for example, so we are here also first initial table is unnormalized data will be here. After the first normal form, something it ensures the no repeating groups. After that, here we have some functional dependencies, which means student ID belongs to student name, course will be belongs to course instructor, student ID and course will be uniquely identifies each role enrollment record. So these two are the key terms. So first normal form. So here the composite key is student ID and course. So what's the problem behind this? Student name depends only on the student ID. We already know that, but not on the course. But the instructor is always depends on the course they have handled. So, but not on the student ID. So we have to split the table, right? So to make it second normal form, we have to split the table so that every non-key attributes will be depends on the whole key. So that we can have like student table, course table, and then enrollment table. Next one, third normal form. So a normal form is in third normal form. We already know that it should be in second normal form. And if there is no transitive dependency for non-prime attributes as well. What is the rule behind this? It is already in second normal form. There's no transitive dependency and no non-key attributes must depend only on the primary key. So it should not depend on non-other key attributes. So always it's satisfy the conditions called x belongs to y. So this is the base table. So it will be having some before normalization. So after that, one student can register for multiple courses and one course can be taken by multiple students. So the combination of both student ID and course ID uniquely identifies a record. So what is the problem behind this? So the functional dependencies like a student ID belongs to student name, course ID belongs to course name, instructor, and then instructor email. So instructor belongs to instructor email. So what is the partial dependency behind this? So the student name depends only on the part of the key, which means student ID. Same course name and instructor email depend only on the course ID. So what is the transitive dependency behind this? The instructor email depends on the instructor, which depends on course ID, so that we have to convert the second normal form, right? So same table will be split into another types. So another table. So student table, course table, and then student ID and then course IDs will be having. So this is what called as enrollment table. Step 3. How to identify the transitive dependencies? So here course ID belongs to instructor. Instructor will be belongs to instructor email. But instructor email depends on instructor, not directly on course ID. So this is where the transitive dependency happens and it violates the third normal form. Then how to avoid this? So again, we have to split the table. So what can we do? So we have to remove this transitive dependency. So we have to split the course table into two. So course ID, course name, instructor, and then instructor email is here. So we have to split the table, which means the course table after removing the transitive dependency. So because it only having course ID, course name, and then instructor. So in the instructor table, we can like we have to create a new table. That's why it will be having only the instructor and then instructor email. Why? Because we have created like this. If I want to change the instructor name, so I just want to change in that instructor table alone. I don't want to change every other tables like course table or student table. That's why we are going for this splitter. So here each non-key attribute depends only on the course ID. Each non-key attribute depends only on the key here instructor. So that's why here third normal form satisfied. So this is the final database in third normal form. So here student table, course table, instructor table, and then enrollment table will be here. So first in student table, student ID, and then student name. So some other IDs will be there. In course table, it only having some course ID, course name, instructor along. So in the instructor table, it contains instructor and then instructor email. Enrollment table, it will be having some student ID and then course ID. Next one, BCNF, which means boys code normal form. So the relationship which should be in third normal form, X should be a super key for every functional dependencies where functional dependency satisfies X belongs to Y in a given relation. What is the rule behind this BCNF? So for every functional dependency X belongs to Y should be a super key, which means a unique identifier of a row. So same, we have to identify the functional dependencies first. We have to identify the candidate key. What is this? So a course ID is uniquely identifies all the other attributes. So course ID is the primary key. So Boy's code normal form for every functional dependency X must be super key. So we have to check each dependencies whether it's satisfied or not. So in the functional dependency, course ID belongs to course name, instructor, and then instructor email. Here course ID is a key, so it satisfies BCNF. But here instructor belongs to instructor email. Instructor is not a key, so it doesn't satisfy this BCNF. So sometimes BCNF will be violated. So how can we change this? So the second dependency, instructor will be belongs to instructor email while it's BCNF. Why? Because it's an instructor is not a key. One instructor can teach multiple courses but has a single email. This may cause also data redundancy. Duplications may arise. That's why here we have considered like course ID, course name, instructor, and then instructor email. Suppose if Dr. John's email changes, you must update it in multiple rows, which means update anomalies happens. But we have to avoid all the anomalies. So how can we change this? Again, we have to decompose the relation, which means we have to split the table into course and then instructor table separately. Final result is now every table has only one candidate key, has no dependency where not key determines another attribute, no redundancy in instructor details. Next one, fourth, multi-value dependency. We already know that it should be in boys code normal form. The table should not have multi-value dependency. So in fourth normal form, we have to keep in mind that we should not have any multi-value dependency. What is this multi-value? It occurs when one attribute in a table uniquely determines multiple independent sets of values of another table, so that it may represent a one-to-many relationship between attributes, not through a key, but through a dependency. So we can formally write it as A belongs to B. So consider this table, student ID, hobby, and then language. So a student can have many hobbies and student can also know many languages, but hobby and language are independent of each other. So that reading repeats for both English and Hindi, swimming repeats for both English and Hindi. So that we have to identify the multi-value dependency. What's the problem behind this? So obviously the table has redundant data. So we have to avoid data redundancy, update anomalies, insert anomalies, and then deletion anomalies. So how to fix? We have to split the tables into two, which means student hobby alone, student language alone. So this is another example. Finally, what is joint dependency? For the fifth normal form, we have to avoid this joint dependency, which means it occurs when a table can be reconstructed by joining multiple smaller tables without losing any information. So if all the joint dependencies in a table are implied by its candidate key, the table is in fifth normal form. So what is it? So this is the highest level of normalizations. We can also say like project join normal form. So it should be in fourth normal form. We cannot be broken down into smaller tables without losing data. So what is the definition of this? A table is in fifth normal form if every joint dependency in the table is implied by the candidate keys. So what's the key idea behind this? Fifth normal form handles cases where redundancy occurs due to complex relationship among three or more attributes. So example table, this is the, here we have been employee, project and department. So here we have to split the table into three smaller tables because everything will be having some duplications. So our employee, project and department independent is everyone is a independent. So what's the joint dependencies here? So employee, project, department having an independent attributes. What's the problem behind this? Redundancy when stored together. So we have to split the table into three. So this is the employee department table, employee project table, and the third table is department project. So here we have apply the join operation. So that's why this is the highest level of normal forms. So we can reduce the data repetencies or duplications in this fifth normal form. So this is the normalization summary. So first normal form, second normal form, third normal form, BCNF, fourth normal form, and then fifth normal form. So you have to keep in mind that first normal form, it should not have any repeating groups. No partial dependency for second normal form. For third normal form, no transitive dependency. VCNF, it should not have any candidate keys. Fourth normal form, it should not have any multi-value dependencies. Finally, fifth normal form for joint dependencies. So that's all about normalization. I hope you all understand. This is some advantages. You just go through it. These are all some drawbacks. So okay, okay all. We'll see you in next class. Thank you.